Hello everyone. In this video we are starting a new chapter in trigonometry. This is going to be special triangles. So this is going to be a two-part video, and my first part is going to deal with the first special triangle, which is a 45, 45, 90. These are the side angles, sorry. The triangle angles. And in my next video, I'm going to deal with the other special triangle, which is a 30, 60, 90. Okay, let's begin. So I'm going to really derive the triangle for you because I don't want to just tell you this is this, this is that, and memorize it, and that's it. I want to show you how it, became so known and how it really works. Okay, what I'm first going to do is draw an isosceles right triangle. You may not know how that looks. It's not really far from just the regular isosceles triangle. The properties are very much the same, with a little touch from this right word. It just gives it a little change. Because an isosceles triangle, just a normal one, has two angles that are the same and two sides that are the same. So, but the isosceles right triangle looks like this. So, this angle and this angle are the same, and its opposite side lengths, this one, so this angle's opposite side length is this one, and this one's opposite side length is this one. These angles are said to be the same. Okay? The only change is that it has a right angle right here. That's all. But this little change actually is going to help us determine a lot of values that we need. Well, one in particular that we're going to do now, actually. So what I want to start with is slowly figure out the values from the inside to the outside. Okay, I'm going to first find out these angle values. In order to do that, I'm going to set each angle to a variable. The same variable, let's say m, because they have the same value. So m plus 90 equals what? What does a triangle add up to? 180, correct? So I'm just adding it up. I'm going to solve for m by using simple algebra. M plus m, that's 2m, plus 90 equals 180. If I just move the 90 over here, basically, 180 minus 90, that's 90. I want to isolate m, so I divide by 2. And doing that gives me m equaling 45. That's brilliant. Okay. Great. So since we know that this m is 45, this m is also 45. Let me just redraw this quickly with our new information that we just found out. So this is 45 now, this is 45, right? And this is a 90. And these sides remain the same. Great, we know the inside. Let's move on to the out. Okay, now I hate saying this, but let's say that this side equals 1. Okay, I hate doing that because you guys probably are, well, how, why? And I'm just gonna, let's just say that, okay? Let's say this is 1, and we said in the beginning that these sides are the same. So if this is 1, this is gonna be a 1. Our job now is to find this hypotenuse value, which is c, and of course we use the Pythagorean theorem. So a squared plus b squared equals c squared, or 1 squared plus 1 squared equals c squared. 1 squared plus 1 squared, that's 2. Oops. And we take the square root, and the square root and the exponent, the 2 exponent cancels, so we get c equaling the square root of 2. Square root of 2. Okay? Now, we are basically done, but there is a big thing that I have to do that requires a little thought. I want to relate to the unit circle for a minute. The unit circle is just this circle that I'm not drawing. Okay, it's not a circle, it's like a potato. Okay, never mind. Let me draw some coordinate Cartesian planes. Okay, so it's this circle where we draw these angles, these triangles. We can draw these triangles all over this this unit circle. That's what it's called. If I draw this triangle right here on this unit circle, it's 45. We count. This is the standard position. That's what it's called. So from here we count 45 degrees up, so that we bring it till the end of our the circle, and this is really the radius of the circle. This length is the radius of the circle because this whole thing is the diameter, and this is the radius, right? And we drop this height, you can say, and it becomes a triangle. Becomes a triangle where this is 45, this is 45, and this is a 90. Okay? See, the rule, why did I bring this up? The rule of the unit circle, the number one rule, is that the radius, we said this is the radius, right? Or the hypotenuse, the longest side of your triangle, which is this, has to be a 1. That's the rule. So the radius has to be a 1. Or, like we said, it's the hypotenuse that has to be a 1. This triangle is the same as this triangle. So let's look at our hypotenuse. Is this a 1? No, it's not. So we have to fix that. How do we make this square root 2 a 1? What do we have to divide it by? We divide because we have to make it smaller, right? So we have to divide. What value do we divide to make it a 1? So if you can't see it right away, it's okay. I'll help you do this. So what are we dividing by this x? We're going to find out to make it a 1, right? So in order to solve this, you can do a couple of things, but I'm just going to multiply by x. And multiply by x on each side, so this x cancels. And I just get the square root of 2 on this side, and x times 1 is x. So I get x to be the square root of 2. That means we have to divide by the square root of 2, and that makes sense because the square root of 2 times the square divided by the square root of 2, they cancel and give you 1. And that's what we want. We want the hypotenuse to be 1. But if you're dividing this by the square root of 2, this side by the square root of 2, you have to divide this side by the square root of 2, and this side by the square root of 2. I know it's a little confusing, but I'll show you that really looks. So our original side lengths were square root of 2, which is our hypotenuse, and the other sides were 1 and 1, right? We said we wanted our hypotenuse to be a 1, so we divide by the square root of 2. Well, you know, it's like whatever you do to one side, you have to do to the other and the other. So if you're dividing this by the square root of 2, you have to divide this by the square root of 2, and this. Okay, so this simplifies to a 1 hypotenuse. This, if you know your algebra, you know your radicals in the denominator, the fact that they can't be in the denominator, you know that you will need to rationalize the denominator by multiplying the numerator and the denominator by that value to cancel out the radicals. So 1 times the square root of 2 is the square root of 2, divided by the square root of 2 times the square root of 2, the radicals cancel, and you're left with a 2. Okay? That's bad, okay. So 1 over the square root of 2 simplifies to the square root of 2 over 2. And since this is the same as that, the answers are going to be the same. The simplifications are going to be the same. So these are our new side lengths, simplified side lengths. So if we redraw our new triangle, final triangle, we get, so this is 45, this is 45, this is 90, and now our hypotenuse is 1, that's what we want. One of our sides is the square root of 2 over 2, and the other side is the square root of 2 over 2. Okay? I hope I didn't intimidate you too much or confuse you. That was not my intention. However, it's not that hard because the first step you do is draw an isosceles right triangle, set each side, each angle to a variable and solve it algebraically. You should get 45. I mean, it's pretty simple algebra. And after doing that, just remember to relate to the unit circle about that rule of the hypotenuse or the radius being 1. So try to make this a 1. So if this was, for example, a 4, right, the hypotenuse was a 4, we need it to be a 1. How would we do that? Well, we would just divide by that number, which is a 4. 4 divided by 4 is 1. And you would just divide each of the other sides by a 4. Okay? But in this case, that was just an example. Alright, so in my next video, I am going to be dealing with the 30, 60, 90 special triangle. If you have any questions, please don't hesitate to ask. Thank you very much.